In this video, we will demonstrate the operation of the conductor selection module of the Sizer Electric software. We will describe the process of creating a project, defining project specifications, entering circuit information, selecting the conductor size, and reviewing the conductor specifications. Finally, we will generate and print various reports. To create a new file, select the project option from the main menu, and then choose New. A dialog box will appear where the project file information must be entered. First, you must define the type of project to be created. This is done in the section located on the left side of the window. There are three options: circuits, circuits with typical data, and grounding grid. For a conductor project, either of the first two options may be selected: circuits or circuits with typical data. The first option creates a blank file to start a completely new project. The second option creates a file with preloaded project specifications, referred to in the software as general data. These specifications contain typical values and configurations commonly used in the industry. For the purposes of this video, we will select circuits with typical data. Next, we will enter the project file name and select the directory where the information will be stored. By clicking the button with three dots, a different drive or storage location may be selected. Clicking within the directory window allows you to define the folder level where the project files will be saved. Once completed, click the Create button. References. After creating the project file, the References window will appear. Here, we enter general project information as well as details of the personnel involved in its development. For the project, enter the project name, client name, project location, and the document, or technical report name, which will be the label displayed on the software reports. Additional project information includes the state, country, and industry segment. These fields are mandatory, as they will be displayed in the references report, which is typically used as the report cover page. Next, enter the name of the person responsible for data entry, including email address and phone number. Then enter the information for the person responsible for reviewing the project, and finally, the information for the person approving the reports. To validate and save the information, click the OK button. If you need to edit the references information later, select Views from the main menu, and then choose References, or click the toolbar icon showing two people. Standards. After entering the project information, the Standards window will appear. This window contains 5 tabs. In the Standards tab, define the electrical code or standard to be used for project calculations. You may choose between the latest edition of the National Electrical Code, NEC, or the Mexican Official Standard, NOM. Next, define the system frequency. Options are 50 Hz or 60 Hz. In the Specifications section, select the libraries used by the software to relate conductor dimensions, weights, and technical references. You may choose between the standard Sizer Electric library, based on average data from multiple suppliers, or the Southwire library, which is based on that manufacturer's conductor specifications. This option increases calculation accuracy by using actual product data. Next, define the maximum allowable voltage drop for circuits during continuous operation. For circuits supplying motors, define the maximum allowable voltage drop during motor starting. These values can later be modified at the circuit level for greater precision. At the bottom of the window is the section, Safety Circuit Length Factors. Here, percentages are defined to be added to circuit length to account for installation losses or waste. These losses are typically related to terrain elevation changes, on-site installation conditions, or additional conductor lengths required at pull boxes and junction points. 2 complementary waste criteria must be defined. The first criterion establishes up to what voltage level, or circuit length the first waste percentage applies. In the example shown, circuits up to 1000 volts or 1000 meters include a 10% waste factor. The second line updates automatically to apply to circuits exceeding those limits. These waste percentages are reflected in the material list or conductor summary generated by the software, but are not considered in voltage drop calculations. In the Additional Fields tab, you can define custom text fields to be used during circuit data entry. These fields may be used to store supplemental information, link circuits to external databases, or capture relevant circuit details such as drawing number, circuit terminals, or circuit status. You may also specify whether each field is optional or required, by selecting the corresponding mandatory checkbox. In the Conductor Sizes tab, a list of commercial conductor sizes used for the selection process is displayed. Each size includes a checkbox. If a conductor's size should not be considered during selection process, simply uncheck it. Some checkboxes may be disabled if that conductor size has been defined as the minimum or maximum conductor size in the general data. Selecting a different minimum or maximum size in the general data section will re-enable the checkbox. In the Reels tab, the minimum and maximum commercial reel lengths for conductors are defined. This tab is not relevant to the conductor selection module. For more details, refer to the Reels module video available on this channel. In the Conduits and Cable Trays tab, parameters for conduit and tray fill calculations are defined, such as maximum allowable fill percentage and minimum and maximum tray widths. This tab is not relevant to conductor selection. For more information, refer to the conduit and cable tray selection video on this channel. Click OK to validate the information and close the window. General data or project specifications. The next step is to define the project constraints or specifications, referred to in the software as general data. These specifications are defined for each load type and voltage level. To open this window, select Views from the main menu, and then choose General Data. Or click the General Data icon on the toolbar. This displays a grid with its own toolbar. The toolbar icons allow you to add, edit, copy, delete, copy to clipboard, export to Excel, or rearrange the grid columns. At the top of the grid there are multiple tabs that classify specifications by load type. Each record represents a set of constraints defined by voltage level for the corresponding load type. Because this project was created as a project with typical data, several preloaded records are visible, containing common industry constraints. If the project had been created using the circuits option only, this grid would be empty, and all data would need to be entered manually. To edit an existing record, select it and click the Edit icon on the grid toolbar, or double-click the highlighted record. This opens the General Data entry window. A general data record is defined per load type and voltage level. For example, these specifications may correspond to a 480-volt motor. Enter the system voltage, define the number of phases, or select DC for direct current circuits. Specify the conductor material, insulation type, and conductor operating temperature. Select the minimum conductor size to begin the selection process and the maximum conductor size allowed for this load and voltage level. During the iterative conductor selection process, if the maximum size is reached, and is still insufficient, the software will select 2 conductors per phase and restart the selection process. This procedure repeats until the correct combination of conductor size and quantity per phase is found. The minimum and maximum power ratings ensure that loads entered for circuits fall within the defined range. In the ambient temperature field, enter the maximum temperature surrounding the circuit. This value is later used to determine the temperature correction factor. The conductor type defines the conductor's diameter, weight, and general specifications. The outer jacket describes the jacket material used for multi-conductor and armored cables. The electrostatic metallic shield defines the required shielding type for medium and high voltage conductors. In the single conductor color table, select colors for each phase conductor, the grounded or neutral conductor, and the equipment grounding conductor. Some systems require secondary phase colors, such as center-tapped delta systems. Right-click to access the color selection menu. In the multi-conductor color table, define the color for bundled cables, including phase conductors, grounded conductor, and equipment grounding conductor. Right-click to access color options. For detailed information on each option in this screen, refer to the online help by pressing the F1 key on your keyboard. Click OK to validate the information and close the window. Circuits. Once the standards and general data of the project have been defined, it is time to enter the circuit information. It is important to note that if the project does not contain any general data records, the following options will be disabled. Therefore, general data must be entered before starting the circuit data entry process. To begin entering circuits, select Views from the main menu and then choose Circuits from the submenu. Alternatively, locate and click the Circuits icon on the toolbar. This will display the circuit grid along with its own toolbar. Using these icons, you can add a circuit, edit a circuit, copy a circuit to use it as a template for another circuit, delete a circuit, Apply or remove filters. Copy grid data to the clipboard. Export the grid data directly to an Excel file. Change the display order of the data. Sort grid columns. Generate a detailed calculation report for the selected circuit. And close this window. Each record in the grid represents a circuit within the project. Each circuit may have characteristics and installation conditions that are completely different from any other circuit in the list. To add a new circuit, click the Add icon on the grid toolbar. This opens the main window for entering circuit information. Circuit Data Entry Window. This window is divided into 6 sections. General Circuit Information. Located at the top of the window and always visible. Circuit Data tab, which contains the electrical characteristics and installation conditions. Additional Data tab, with user-defined fields, colors, and notes. Results tab, where the conductor selection conclusions are displayed. Specifications tab, which defines and describes the circuit conductors. Calculation Report tab, which presents a technical summary of the conductor selection process. Entering circuit information. Enter the circuit number or name, then press Enter. Next, enter the MCC or panel board tag from which the circuit is supplied. This field is a combo box that is populated with previously entered MCCs, or panel boards to simplify data entry. Enter the equipment or load tag, and select or clear the checkbox to define whether the load is active or standby. Enter the area where the load is located. Provide a brief load description. If general data was entered for both AC and DC systems, 2 buttons will appear. Select the system type. This filters the system voltage, number of phases, and operating temperature options, to display only those applicable to the selected system. If general data exists for only one system, a single button, AC or DC, will be displayed. Select the load type from the combo box. Note that this list includes only the load types previously defined in the general data section. Some load types require additional information, such as motors and transformers. When a motor is selected, a secondary window opens to enter motor details, including motor type, motor voltage, locked rotor code letter, service factor, NEMA design, efficiency type, starting power factor, and motor duty. These parameters are used to adjust the motor full load current during ampacity-based conductor selection. Press F1 for detailed help. Click OK to validate and close the window. Load information can be edited later by clicking the 3-dot button, located next to the load type combo box. In the same combo box, select the system voltage, number of phases, and ambient temperature. This information links the circuit to the corresponding general data specifications. You can view the associated general data by clicking the 3-dot button next to the field. The general data code shown in the table header provides a precise reference for this relationship. Select the Circuit Data tab to enter electrical load information and installation conditions. Electrical and installation data. The first field in this section is power. Here enter only the numeric value, then select the units. Ensure that the value falls within the minimum and maximum power limits defined in the general data for the selected load type and voltage level. Sizer Electric includes a motor library with typical efficiency and power factor values. When motor power is changed, the system prompts you to update these values. Click Yes to update them, or No, to retain the existing values. Sizer Electric calculates load current based on code recommendations or balanced current formulas. However, if you want to use a different current value, you may enter the nameplate current by selecting the corresponding checkbox. This enables the current field. The software validates that the entered value is within plus or minus 30% of the code recommended current to ensure data consistency. Leave the checkbox unchecked to keep the calculated value. Enter the circuit length in meters. Define the number of conductors in the circuit, considering only current-carrying conductors and the neutral or grounded conductor. The equipment grounding conductor is defined separately. Select the conductor type, single conductor, multi-conductor, triplex, for triplex or quadruplex arrangements, or bare conductor. If bare is selected, the software restricts the installation method and material to air only. Enter the power factor and efficiency of the load. If the conductor is a feeder, enter the demand factor. For other loads, leave the value at 1. Next, select the installation method. A secondary window opens to define installation conditions. For cable tray installations, define the tray type, rung spacing, and whether maintained spacing is provided between conductors and other circuits. If conductors are continuously covered by a tray cover for more than 1.8 meters, check the corresponding checkbox. The adjustment factor field initially displays a value of 1.0 because it is calculated during the iterative conductor selection process and depends on conductor size. Once calculations are complete, the actual factor used will be shown. In the Adjustment Factors section, additional factors affecting ampacity may be entered, including harmonic content per IEEE 142, grounding of metallic shields, and any user-defined adjustment factor such as safety or tray grouping. The product of all factors is shown as the tray derating factor. Press F1 for detailed technical guidance. Click OK to validate and close the window. Select the predominant material of the installation based on the longest segment, if multiple materials are used. Select the maximum connector temperature, choosing the lower value between the source and load ends. This limits the allowable ampacity to prevent hot spots. Select the insulation level. For low-voltage circuits, only 100% insulation is allowed. Medium and high-voltage circuits may use 100%, 133%, or 173%. Define the maximum voltage drop for the circuit. The default value is inherited from the standard section, but it can be modified here at circuit level, to distinguish feeders from branch circuits, and to allow the variations required in the project. Select the checkbox to verify the conductor short circuit thermal withstand capacity. This is optional for low-voltage circuits and mandatory for medium and high-voltage circuits. Enter the short circuit current, fault duration, and conductor maximum allowable instantaneous temperature rise. If the short circuit current decrement option is selected, the software calculates the actual current at the load end including conductor impedance, preventing conductor oversizing. Click OK to validate and close the window. Grounding and shielding. To size the equipment grounding conductor, select the corresponding checkbox. Choose the protective device type. The software suggests breaker frame and settings, or fuse ratings, based on load power, which should later be verified through a coordination study. Sizer Electric automatically increases the grounding conductor size proportionally, if phase conductors are upsized. Click OK to confirm. If the conductor includes a metallic electrostatic shield, induced voltage and grounding spacing can be calculated per IEEE 525. Enter the installation configuration, conductor spacing, shield type, and maximum allowable shield voltage. Click OK to confirm. In the Additional Data tab, enter user-defined fields, adjust conductor colors, and add notes as required. When all data is complete, click Calculate. The Results tab activates automatically, displaying conductor selection based on ampacity. Voltage drop. Motor starting voltage drop. And short circuit criteria. Along with conduit size considering that all circuit conductors are installed in the same conduit. You may override conductor size selection using the user selection frame. Sizer Electric validates compliance of the conductor entered by the user and displays warnings or errors as needed. The Specifications tab displays detailed conductor data linked to the library, including availability status, conductor identification, mnemonic code, and technical datasheets. The Calculation Report tab provides a detailed technical summary of the selection process. Click OK to save the circuit. To generate a complete circuit report, select the circuit on the grid, and click the Calculation Report icon on the toolbar. You may also generate tabular reports for all circuits with the option Reports in the main menu and then selecting circuit data from the menu displayed on the left. Reports can be printed, exported to multiple formats, and customized using the report template editor. These are the basic steps for using the conductor selection module in Sizer Electric. For additional information, refer to the user manual or the built-in help system available from the main menu or by pressing F1 at any time. Thank you for your attention. We also recommend viewing the complimentary videos on cable tray and conduit sizing, reel optimization, and grounding grid design to complete your knowledge of the Sizer Electric software.